So we're out here today in the field, here by the solar panels and the pump house, to make a video that I've been wanting to make for a while now. A lot of people want to check out what's inside, what I've done, what I've added, and kind of just want to share what I've done. Alright guys, let's go take a look. Alright, so we're out here in the field. Here's our solar array that I put up this summer. And just before that, I went ahead and built this shed that serves two purposes for us. First purpose is to have all the plumbing and the pumps for our water supply, which is a well that we have drilled a few summers back, almost 3 summers now, 480 feet deep, so it is a pretty deep well, but we use a DC well pump that runs off the solar here, that pumps to this water tank, then into our shed here that houses all the plumbing, pressure tank, pumps, and pumps it up to our house. And the goal here was to get everything off grid using nothing but solar battery. And we do use our local utility grid as backup. We still run off of utility. You can see the power line here. It does supply 220 volt down to the pump shed and the solar shed down here as backup only. So far we're 100% off grid, both by solar generation and battery storage at night. That's the goal, and the ultimate goal is to get the whole house off of grid and be self-sustained out here. These are 12 290 volt 290 watt panels. They're made by a company called Trinastar, and you can see there, hopefully the camera picks it up, the stats, but 290 watts. They're an open circuit of 44, almost 45 volts, and they're true to their word. They get pretty close to 290 on a good sunny day. It's about 11:30 in the afternoon. It's in December, and we got this set up at a 30-degree angle as kind of our average angle for year-round. But you can see, nice bright day. I'd say we're getting about 250 watts per panel on a full load and full draw, so it does a pretty good job. For these panels over here in the field, we have about 36 more panels to install. Those are a little beefier, 380 watts, but that's for our future project that's going to utilize the rest of this field for that, and on the house itself. We do have these combined into a combiner box that goes into conduit through a trench to the shed, and goes into the shed and supplies the inverters that are also inverter slash charge controllers for our batteries. So far, not a lot of battery bank in there. It's just enough to run the pumps and the well pump to feed the tank, and ultimately to feed the house and the other applications on the property for water. These are set up in series and parallel. 2 in series, 6 in parallel. You can see the 6 different parallel connections here, and it combines down to 1. And we'll walk into the shed and see where that comes in. It's not a finished product yet, but it's getting close. We're inside the shed now. Let the camera focus. The wires come in very crude at the moment. Excess wire comes in, and then subsequently supplies these 2 inverters that are MPP solar controllers, charge controllers, and inverters. These inverters are a total off-grid combo inverter, or all-in inverter, and these are the PIP or PIP controllers. This one is the 3048 LV-MK. They're 3,000 watts out of 48 volt battery setup. So right now we have capability of 6,000 watts, which is more than we need in this shed, because all we're running right now are 2 pumps, well 3 pumps, 1 well pump and 2 supply pumps. Supply pumps are two AC pumps that are in here. This one here is just a basic half horsepower pump, which is our backup for drawing shallow from the well when there is no solar to be had, or if it's a rainy day or we have no battery left. We have the ability to use utility backup or generator backup to draw at least shallow from the well, roughly about 90 feet in, so we can enough to fill the tank up over the day. But the main pump is this red line. I believe it's a 3/4 full horse supply pump that draws directly from the well tank, or the storage tank outside, which is a 2,600 gallon tank, and then feeds into this kind of my design manifold that supplies 5 different sources on the property. The 2 most utilized ones are the main house and a guest house, and the hose bibs around the immediate property. In another video I'll go into all these valves and what I've done and how I've utilized this kind of makeshift manifold to supply everything. Mainly what I wanted to show is the wiring, the setup, and what I have going down here for the solar. It starts off with a sub panel here that powers everything, and this is all sub paneled from the inverters. And right now we're only supplying 3 things or 4 things. You saw that I had an RV outside, and that supplies the power to a 30 amp 110 for the RV, but the big ones are the outlets inside. This outlet is just a auxiliary outlet from the inverters that power things like the heat lamp, just a power strip that powers things like the laptop, some of the other monitoring software that I have for the batteries and solar. But mainly it has this plug for the heat lamp, and I have a leveling, a Wi-Fi leveling tank level for the water level. It's actually a Bluetooth device on top of the water tank that relays to this unit here, which then sends it to Wi-Fi so I can monitor my tank level from anywhere. It gives me alerts like when it's low, if it's reached a certain percentage filled, or if it's full and overflowing, I know to turn it off. Eventually I'll have an automatic shut off, but I like to have that control and knowledge anywhere how much water we have and how much water we can use. These controllers right now are running off of a parallel connection, so they're hooked together and share the load when the pump does kick on, and it's monitored by this software, which is Watch Power. That's their brand, or their utility software that they use to monitor the PIP controllers out here. It tells me things like how much solar power we're using and what is the total output. Right now we're not using anything, 23 watts. That's probably just the laptop and small LEDs and on the different devices here, and just minimum draw. The pump that supplies the house, that draws from the water tank, is a like I said, a full horsepower, and let me confirm that. I can't read the label here, but I'm pretty sure it's a full horsepower, but it runs about 1,700 watts, 1,800 watts under big load. And these inverters don't even blink. They handle that really well. The RV outside, and I'll just give a quick glance at that. It's a 28-foot Sunseeker, and it has AC, gas heater, refrigerator, but the big one is the refrigerator. We like to keep going and keeping it cool so it's not getting mildew or sitting in there without any cooling. But when that first starts up from a dead start, or hasn't been cooled in a while or turned on in a while, it runs about 1700 watts as well. So on full load down here, when we have the pump going, all of the minor devices like the laptop and heat lamp and whatnot, and the RV running, we're looking at about 4,000 watts, and that's just max draw. Once the refrigerator gets to temp, it standbys, the whole rig standbys around 300 watts or less. And you saw on the software, if I can get close there, about 36 watts just by standby, 14 watts, so it's barely using anything. Right now you can see that the solar panels, this is just a crude little diagram or representation of what's going on, but they show that the power from the solar panels is in battery mode, so it means it goes straight to the battery or straight to the load. So 14 watts or 25 watts right now, it's coming from the solar panels going straight to the load. The rest of it is being dumped into the battery. And I could probably simulate by turning on. Right now I have the RV off, but this is the breaker, 30 amp breaker for the RV. If I turn it on, you can almost hear immediately that the fans and the inverters kicked on, sensing that larger load draw. We're still in battery mode, so it's coming straight from the batteries, but more so the solar panels, because we're generating about 3,000 watts out there on the panels or more. Right now we're pulling 1,812 watts, so that kind of rings true to the 1,700 or 1,800 I said the pump would run. And right now it says we're pulling about 629 watts from one inverter and 800 from another inverter, the other inverter. So together they're pulling about 1,300 watts. And that will ramp up as the load is more steady, and it knows, and the computer inside determines how to divvy up the load between the two inverters. It will even out and ramp up and start drawing more and more from the solar panels, or as much as it can from the solar panels, and then it supplements from the battery. That's how we have this set up. The battery for these, I have built a well, that lighting's pretty bad. There we go, a little better. Let's see if I can get in shot here. Hard to see, but it's a 14S LG Chem 2N batteries, or 2.1N batteries. I got them from batteryhookup.com. Great deal. Great power density on these. Each one of these modules is 120 amp hours. So each one of these is 120 amp hours, and I believe 3.6 or 3.7 nominal voltage. So in a 14S setup, I'm getting a what I would consider 48 nominal, but it's roughly around 50, 52 or 53 volts, 58 max, and then a cutoff around 42 volts. I don't ever let them get them down that far, but it does have that range. And these batteries can handle 120 amp hour discharge, but I'm nowhere even close to that with these. Even at 4,000 watts, we're nowhere close. But nonetheless, this is about a 6 plus kilowatt hour battery, which is enough to run these pumps and whatnot overnight if there is no sun the next day. It's good for about 24 hours of use for backup, but we try to do most of our big water draws, like filling up the pool or showers, dishes, loads of laundry, stuff like that, during the day, so we're using nothing but solar and trying to use the batteries as minimal as possible. That way we're not cycling these too much and use them more of a backup or nighttime use. I'll try to make a video of just these inverters by themselves. There's a lot going on here, including data cables, input output, battery cables, current sharing between both units. I have sub panels for the grid power to the inverters. This is just a panel that I use to supply the backup power, so they can go off of a kind of a line mode or a switch mode. So if there is no more power via solar panels or battery, it automatically switches over to utility seamlessly, and it does it pretty well, where you don't even notice that it's switched over, especially if you're not down here in the shed at the time. But mainly so that if we do lose battery, do lose solar, we at least have some utility backup, and that eventually be replaced with an automatic start generator. But right now it's off our local grid, our power company. That power comes in from the main house breaker, which is the utility line, into this box, and then supplies through these conduit. It goes above, it comes over here. You can see I have them labeled grid in and inverter out. So grid comes in, supplies the inverters with their necessary backup AC line, but the big one is the inverter out, which is this guy. Takes the total output from both these inverters, combines them into this output, and the output comes over here and supplies this sub panel, which is all grid power, and I got it labeled here as main shed inverted power, and it shows me everything that's on here. I got a couple that are going to be used for other applications coming up, but we have the outlets, well pump, feeder pump, and up here you can see the lines coming out that feed these two pumps over here. The second part of this shed has to do with this battery pack, which I featured in another video, mainly to show off the new 48 volt tender. It's a battery charger that tends the batteries or keeps them topped off. Shouldn't have that there, that I showed in the video, and I'll link I'll put a link in the description or in this video to show that video. But really what it is, it's a 48 volt AC charger that charges 48 nominal voltage for this battery pack, which is a 4S, 4 12 volt AGM batteries in series. These are Everstart, Walmart brand or box store brand batteries. We don't need a ton of power for the well pump. It is a DC pump. It runs off of 400 watts or less, depending on the depth. We're pretty low or deep. We're about 400 feet, so it does push about 450 watts at startup. Tapers off a little bit with flow, but the control box for that is here. And I have that off of just a 100 amp breaker. That breaker is not meant for much more than just a power switch or a kill switch, but I do have this controlled by a relay, and it's pretty crude right now, but it's a relay that I have that's Alexa controlled. So when I know my water is getting low in the tank, or the sensor tells me the tank is low, I can just say, hey Alexa, turn on well pump, and it'll indicate that it turns on, and it'll fill up through the day. And then once it gets to a certain level, it'll tell me that it's 90% full or more, and I can tell it to turn it off. Eventually I'll have this on a setting where it'll just turns off, turns on at certain percentages, but this works for now because 2,600 gallons for our one family situation, 4 or 5 people. 2,600 gallons for us during the winter time for showers and basic house use lasts us about a week, sometimes more. In the summertime, a lot less, because we have the pool, hot tub, things like that take up a lot more water, gardening, ag water, stuff like that. That gives you a quick little overview of what's going on in the shed here. These are the hybrid inverters that eventually will have 9 of them in here. That sounds like a lot, but we're going to be going full off-grid, and with a hybrid situation, we can either fully support all loads of the house and the property, or at least supplement to a large degree, because these are hybrid, so these will kind of have a grid tie or a grid assist to them. We can't do grid tie out here. Our local company won't give us contracts to pull that much in a solar contract, which is fine. Our application is more of an off-grid battery backup situation anyway. Grid tie just doesn't work for us, or won't do what we need to do fully. So having more control over the usage and the backup and what we use for storage is more up our alley. These are great because you can, if you're pulling 10,000 watts from the house, and these are rated for 2,400 a piece, and they will take it straight from the solar panels straight to the load and bypass the battery altogether, so you can take full advantage of the efficiency, which is as good as it can get from the solar panels to the inverters to your AC load. So with 2,400 watts a piece on these, you can take 4,800 or round it up to 5,000 watts supplemented, and your bill will only reflect a 5,000 watt usage at the time, which is great. That's saved. That's money saved and energy used wisely there. But I'll go into depth on these. A lot of people are using these MPP solar and the PIP controllers for their off-grid situation. They're not top of the line, and they're not bottom of the rung either. They're just a mid-grade, all-around good unit. There's a huge community on these of people using these for off-grid situations. The nice thing about these are they're smaller and they can be paralleled. Both of these versions can be paralleled up until 9 units each. I wanted a full off-grid system for the pump house, because water is really important out here, and we have a small array on the house already for our 110s for lighting and whatnot up at the house. So between water and the house, we're pretty much off-grid. But the big units like the AC, the HVAC, the heater, pool pumps, hot tub and stuff like that run off the big 220 and split phase will have to be supplemented by this upcoming project, and I'll feature those in videos as I start installing this. But it's a start. I built the shed, built the array out here, or at least the ground mount for the array, and that's 12 panels. We have 8 panels on the house right now, so we're utilizing about 20 panels, which is a good start to kind of supplement our energy usage. And eventually we'll have 4 rows of 12 down here in the field for a 48 panel array in the field, which is going to be a large array, but we're going to have the battery backup to support that, so we won't be just generating and not using. We're going to be generating and storing at the same time. And just before I conclude this video, because it is getting kind of lengthy, real quick, there is the 30 amp receptacle for the rig, for the RV. That's just a standard 30 amp receptacle, RV receptacle with a cord that goes to this. We use this pretty frequently in the summer, so we like to have it charged and ready when we're going to hit the road. But the big storage project coming up is we have 104 of those modules that I said earlier, which are and that's going to be upside down. Maybe I can do this. It's the LG Chem batteries. They're usually used for EV applications, electric vehicles and scooters and larger DC motor draws, because they do have a pretty high amp output. I think it's 1.5 C, so 180 or 180 plus amps that can be pulled from each module. So a large battery bank of 100 plus, pulling only a few amps per module, is a good way to store without taxing these batteries too hard. That would continue its life way past specs. And I think these are rated for 2,500 cycles or even 5,000 cycles. So hopefully we can get a good 10 years or more out of these batteries if we, only use them for very short cycles or even low cycles. But there's a start. There's a start on checking out what we got going on. I hopped on here on YouTube to kind of get some feedback on what I've got up here and what other people have been doing in the community with these inverters, and especially these hybrids. They seem to be taking off in the community pretty well and got a good following. But for right now, that's all I have. Got any questions, leave them in the comments below. I kind of flew by everything here. So if you see anything you have a question on, or kind of want to know why I did what, or why the setup is the way it is, love to talk to people about it and see what ideas you have out there. Alright, till next time. See you guys.